Question 13 shows two circuits. They both contain a 6 volt supply, and in both cases it says the supply has got negligible internal resistance. In other words, the question doesn't involve internal resistance. And it says in each case these circuits are operating at a 2.5 volt 0.25 amp bulb L. So part A, calculate the resistance of the filament lamp when working normally. Well, what does working normally mean? That's what it tells about the bulb. It's a 2.5 volt 0.25 amp lamp. So when it's working normally, what's the voltage across it? And how much current should be flowing through it? Clue there in the question. You know the voltage, you know the current for the lamp when it's working normally. So how do you find the resistance of something when you know the voltage across it and you know the current through it? If you need me to tell you that, you really shouldn't be doing this exam. Part B, referring to figure 5 now. Calculate the resistance of the resistor that should be used for R. So we've got a 6 volt supply. It's a 2.5 volt bulb, so we've got to choose the value of R so that the voltage across the lamp is 2.5 volts. When we do that, the current through the lamp will be 0.25 amps. So if there's 0.25 amps flowing through the bulb, because it's just a simple series circuit, there's 0.25 amps flowing everywhere. So we know what the current in the whole circuit is, 0.25 amps. We know the voltage supplying the circuit. We know the current in the whole circuit. So we should be able to work out the resistance of the whole circuit. And once we know that, we already know the resistance of the bulb, so we should be able to very easily find the other resistance that's in the circuit. An alternative method is to say that if we choose the value of R so that the voltage across the bulb is 2.5 volts, then we can work out what the voltage across R must be. It's going to be 3.5 volts, isn't it? And then we can say, well, the battery voltage is being shared out. So L gets 2.5 volts, R gets 3.5 volts. So that tells us immediately that R must be a bigger resistor because it's getting a bigger share of the voltage. And we can use that ratio, the ratio of 3.5 to 2.5. We could use that ratio to find what the resistance should be, because the two resistors will be in the same ratio as the two voltages. I still think finding the current is. Part C, calculate the total resistance of the circuit in figure 6. So we've worked out what the resistance of the bulb is. This is the same bulb as before. We've got to find the total resistance. So what have we got? We've got the bulb and another resistor in parallel. So we can work out the resistance of those two in parallel, and then we've got a resistance in series with that pair. So once we've worked out the parallel pair, we can then put the value we get for those two in series with that one and get the total resistance of the circuit. Part D, explain which circuit dissipates the lower total power. Now there's all sorts of ways of doing this. We could find the power in each resistor separately, or we could look at the circuits as a whole, and we've got a choice of different formulas for power on the data sheet: P equals VI, P equals I squared R, P equals V squared over R. Now I think if I was going to find the power for the whole circuits, given that I know what the voltage for the whole circuit is, in each case the voltage for the whole circuit is 6 volts, and we either know or can easily find the resistance for the whole circuit, so we could use P equals V squared over R for each circuit. Find the two power values, and you've just got to explain which one has got the lower total power. So that's simple enough. There is actually a way of doing it where you don't bother working out any of the powers. Just think about the two batteries. We know that another formula for power is P equals V times I. We know that the two batteries have got the same voltage, so we think about the current. Which battery drives the smaller current? This one, where you know the current in the bulb is the same as the current in the whole circuit, or this one, where you've got the same current in the bulb but a more complicated circuit. And which of these two circuits has the smaller current flowing through the battery? Once you've spotted that, you can explain which circuit dissipates the lower power, and you don't even need to work out any of the values. But if that idea is too confusing for you, work out the